Folks, let's take a few minutes for some plain talk about a serious problem: silicosis. Silicosis is certainly not a new disease in the mining industry. Hippocrates noted the symptoms of silicosis as early as 400 years before Christ. Through the years, it's been called such things as sewer disease, potter's rot, rock TB, tunnelitis, and miner's asthma, to mention a few. No matter what you call it, well over 1 million workers in a wide range of industries throughout the United States are exposed to this very serious disabling disease, which results from inhaling dust containing silica. While all dust is bad to breathe, some's a lot worse than others. Silicosis is a lung disease which results from inhaling dust laden with silica. Quartz is a typical silica material. The human body is truly an amazing network of biological systems which work together closely to sustain life. The respiratory system, made up of the lungs, air passages, and alveoli, is capable of removing the vast majority of impurities we inhale with each breath. Understanding the basic mechanics of dust and the respiratory system will help you better understand the serious disease, silicosis. With each breath you take, you inhale airborne dusts, some of which you may be able to actually see, most of which you cannot. As air is inhaled through the nose and mouth, it continues toward the lungs through passageways which are constantly divided into smaller and smaller airways. It is at the end of this complex network that the actual transfer of oxygen takes place. These small air sacs are called alveoli. These structures are very tiny and delicate. Fortunately, most dust never reaches this deep into the lung. As we said earlier, all dust is bad. Some is worse than others. Let's look more closely at dust and how it affects this delicate lung tissue. Dust, like many other things, comes in a wide range of sizes. Since dust particles are extremely small compared to most things, they are measured in microns. How big's a micron? Well, 1 micron equals about 1/26,000th of an inch. That's still pretty hard to visualize. Let's compare it to something most of us are familiar with, the human hair. Human hair is about 80 to 120 microns in diameter. The smallest dust that can be seen is approximately 50 microns in diameter. Dust smaller than 50 microns is invisible, but it's still there and may be inhaled. The respiratory system does an amazing job of filtering the air we breathe. Dust particles larger than 10 microns are almost completely filtered by the upper respiratory tract. Tiny hair-like structures called cilia completely cover much of the respiratory system, and through a continuous sweeping action help to remove dust which has been inhaled. Coughing up of mucus after heavy dust exposure is good evidence that this cleansing process is in working order. Serious health problems are created by silica dust smaller than 10 microns. The smaller the silica dust particles, the deeper they penetrate into the lung and the more serious the injury to lung tissue. While new medical research has provided a wealth of information on many lung diseases, there remain a number of unanswered questions concerning silicosis. Let's examine some of the things we do know about silicosis. There are 4 primary contributing factors in determining whether or not an individual who is exposed to respirable free silica will contract silicosis. First, we must consider the size of the silica dust particles. As we said, silica dust particles larger than 10 microns are usually filtered out by the nose, throat, and other filtering mechanisms of the respiratory tract. Most silica dust particles smaller than 10 microns lodge deep in lung tissue and cannot be removed. These extremely small particles cause the body to take defensive action in an effort to protect tissue from further injury. The lung releases cells called phagocytes, which act much like the lung's trash collectors. These cells surround the silica particles in an effort to protect the lung. They die in the process and form scar tissues deep in the lungs. This continuous effort to isolate foreign materials results in the gradual buildup of scar tissue. It is this gradual buildup which reduces the lung's ability to take on oxygen and give off carbon dioxide. With silicosis, the gradual buildup of scar tissue usually occurs over several years of exposure to silica dust. The amount of free silica is an important factor in determining how likely you are to develop silicosis. Free silica is a dioxide of silica, which is a primary ingredient making up the Earth's crust. Silica is found in over 60% of all the rock on Earth. Some types of quartz and sand are nearly 100% pure silica, but silica is found in varying percentages in most materials that are mined commercially. Free silica is particularly troublesome when drilling, crushing, or milling apparent material which has a high silica content. The higher the silica content, the greater the hazard. Another important factor in determining your likelihood of contracting silicosis is your length of exposure to a dusty environment. Short exposure to silica-laden dust produces minimal damage to lung tissue. The longer you work in dusty conditions, the greater the damage. The relationship between the amount of respirable free silica in the air you breathe and the length of time you spend in these dusty conditions is used to determine your TLV, or your threshold limit value. Threshold limit values are used by regulating agencies and management to determine maximum safe exposure levels for employees working with toxic substances such as silica dust. The smaller the silica dust particles, the shorter amount of time an employee can work safely while exposed. So far, we've looked at several factors which contribute to silicosis. First, the particle size of silica dust is extremely important. Remember that silica dust below 10 microns is what seriously damages the lungs. You can't even see dust this small, but it's still there. Remember that the amount of silica found in the material you work with is also an important factor. The higher the amount of free silica, the greater the risk. The length of safe exposure also depends on particle size and the amount of silica present in the dust you breathe. Much less is known about the final factor we should examine. That is, individual susceptibility. This simply means that some individuals are more likely to get silicosis than others. Medical research so far is at a loss to explain the reason for this. People working under identical conditions don't necessarily stand the same chance of contracting silicosis. Scientists speculate individual susceptibility may be due to some individuals' lungs' ability to cleanse themselves easier. General health and smoking may also be important factors. They are, however, sure that physical strength and macho mentality play no role in determining whether or not an individual will suffer the crippling effects of silicosis. Silicosis has buried thousands of tough guys who fail to adequately protect their lungs from silica dust. Silicosis is a very complex and progressive lung disease, and physicians use a series of complicated measurements and tests to determine how much damage has been done to lung tissue. For our purpose, we'll look at silicosis in 3 basic stages. Stage 1 of silicosis is unlikely to be noticed by the person. There are few, if any, symptoms noticed, and an individual may go undiagnosed. A qualified physician can detect early scarring in the lungs by careful examination of chest x-rays. However, it is absolutely necessary for him to have a good occupational history to help him decide whether the scarring is caused by dust. Early diagnosis is much easier if the physician knows you are presently or have been exposed to silica dust in your work. Early diagnosis of silicosis is especially important. If you take the necessary precautions immediately, you may not suffer the permanent and possibly fatal effects of silicosis. Persons with stage 1 silicosis who continue to be exposed to silica-laden dust will likely progress to stage 2. In stage 2, an individual may notice shortness of breath, especially during work or even moderate exercise. An individual with silicosis which has progressed to stage 2 is also likely to have a dry, hacking cough. With stage 2 silicosis, scar tissue in the lungs is more clearly visible in x-rays. In some cases, stage 2 silicosis can progress into stage 3 even if the person is no longer exposed to silica dust. In stage 3 silicosis, an individual's breathing may be labored and oxygen may be required to ease breathing difficulty. A person's physical abilities are much below normal, and even a short walk can be extremely strenuous. Resistance to other diseases such as tuberculosis is greatly reduced. In stage 3 silicosis, the scar tissue in the lungs may eventually cause so much strain on the heart that it cannot do its work as it should. This results in increased shortness of breath and swelling of the feet and legs. Stage 3 silicosis is incurable and often is either directly or indirectly responsible for death. Since silicosis has no cure, early detection is essential if the victim is to live a nearly normal and useful life. Silicosis can be detected even in the earliest stages by careful interpretation of X-ray films. Remember, in order for a physician to properly review your X-ray, it is essential that you make him aware of your work history and medical background. Since evidence of silicosis may take several years to surface, this step is extremely important. A pulmonary function test is also a useful tool in the evaluation of disability from silicosis and other lung disorders. This is a test which checks the capacity of the lungs. A yearly examination and comparison of test results will help detect deterioration of the lungs. Remember, since there is no cure, early detection is extremely important. The only thing better than early detection is prevention. Controlling dust at or near the source is the single most effective step in helping prevent silicosis. Engineering controls include the use of dust collectors, dust control devices, water, proper exhausting of dust, dilution ventilation, and the isolation of workers from dusty processes. Many of these controls depend on management's commitment to providing a healthy work environment for their employees. Employees have a responsibility to follow safety procedures and to use and maintain dust control equipment provided. Even with good dust control systems in operation, there are times when use of proper personal protective equipment is necessary for short periods of exposure. If you use a respirator, make sure that it is equipped with the proper filter and fits properly. Remember, all dust below 10 microns is extremely hazardous. Personal respirators should be used to complement engineering controls, not to replace them. Use the dust controlling devices that are provided, such as water sprays, detergent kits, water wagons, and exhaust ventilation systems. Do not operate dust generating equipment unless the dust control devices are installed and working properly. Keep floors and work areas free from dust or keep the area wet down. Vacuum instead of sweeping. When possible, avoid areas where dust is present or stay upwind of the source. If you see a dust control problem, report it to your supervisor. If you have to clean up areas or make repairs that may generate dust, wear a proper fitting government-approved type respirator. And be sure to have an annual chest x-ray interpreted by a qualified physician. Folks, this is Andy Griffith reminding you that use of proper dust control equipment and procedures can prevent silicosis. Be smart. Don't be sorry. A man has no greater wealth than his health. Appreciate it.
This has been a presentation of the Mine and Quarry Division of the North Carolina Department of Labor.
The Refractories Institute is a national trade association representing refractories, manufacturers, and their suppliers. One role of the Refractories Institute is the continual monitoring of health and safety aspects of refractories manufacturing. This presentation will examine the health and safety aspects of crystalline silica as it pertains to refractories. Of all the many minerals found on planet Earth, the most common is silica. Most commonly found in sand, silica is a substance to which we are exposed daily, be it on beaches or virtually anywhere. Silica is also a substance that we encounter in one form or another virtually everywhere. It is, however, silica's use in refractories which we want to address here. In 1983, the National Institute of Occupational Health and Safety estimated that 3.2 million workers in 238,000 plants in the United States were potentially exposed to crystalline silica. More recently, in 1987, the International Agency for Research on Cancer, IARC, in its report, Evaluation of the Carcinogenic Risk of Chemicals to Humans, Silica and some Silicates, made two conclusions. One, there is sufficient evidence for carcinogenicity of crystalline silica to experimental animals. And two, there is limited evidence for the carcinogenicity of crystalline silica to humans. To address these conclusions are first Dr. Morton Korn, director of the Department of Industrial Hygiene at Johns Hopkins University and an early director of OSHA, and Dr. John Craighead, chairman of the pathology department at the University of Vermont, and author of more than 200 articles on asbestos, silicosis, and diabetes.
IARC reached the conclusion that there is sufficient evidence in the scientific, peer-reviewed literature to classify crystalline silica as an animal carcinogen, meaning different species of animals given quite high amounts of this material by inhalation or by insertion in the body by artificial means so that it is in the lung but not inhaled, will develop cancer. IARC also reached the conclusion that that type of evidence does not exist for the human condition, that there is limited evidence and there is not persuasive evidence that crystalline silica is a human carcinogen. Inhaling crystalline silica is not per se a health hazard. It's a potential health hazard. We should be concerned about the presence of free silica in the air, but the amount of it and the particle size being of importance because it determines where it goes after inhalation. Therefore, we measure the amount of free silica in the air, and we're concerned with the particle size because only that which will be inhaled and reach the lung is of concern.
It is this respirable dust that can aggravate upper-level respiratory conditions. Long-term exposure beyond acceptable levels may cause silicosis.
Silicosis is a disease of the lungs that results from prolonged exposure to high concentrations of very fine particles of silica. It seems as if the body responds to the accumulation of these particles in the lungs by walling them off with a fibrous tissue coat. And as the particles linger in the lungs, the fibrous coat becomes larger and larger until it encroaches upon the lung substance, the substance of the lung where we breathe. Even then, silicosis is not a serious problem. It is only when these accumulations of fibrous tissue destroy or damage sufficient amounts of lung that normal exchanges of gases cannot occur.
The particle size able to enter the lungs is less than 10 microns in diameter, or 8 to 10 times smaller than the diameter of a human hair. OSHA has established a permissible exposure limit, or PEL, of 0.1 milligrams per cubic meter of air, based on an 8-hour time period. Dr. Korn comments on this standard.
The federal government has concluded in the standard enforced by the Occupational Safety and Health Administration, which applies to all those at work, that a quantity of 1/10 milligram per cubic meter breathed for 45 years, 50 weeks a year, 8 hours a day is acceptable and involves minimal risk.
It is still, however, the task of companies to protect workers from respirable silica exposure. Can industries and individual companies reduce the amount of crystalline dust inhaled by workers and prevent silica-related disease?
When industry acts to prevent excessive concentrations of dust in the air, it will eliminate the potential for the disease silicosis occurring among workmen. We have a good example in Vermont. In the granite industry in this state, during the early 1900s, silicosis was common. In the mid-1930s, public health investigators learned that fine particles of silica in the air workmen were responsible for silicosis. When these fine particles were eliminated by simple means for cleansing the air, silicosis disappeared almost overnight. It is no longer a problem in the granite industry of Vermont.
Today, exhaust ventilation at the point where dust is generated, enclosure of operations, and use of respirators are all methods used to reduce the amount of crystalline silica inhaled. Silica and silica-containing materials can be used and handled safely when appropriate dust controls and work practices are followed to limit exposure to respirable silica dust. A first step in handling is knowing the risks of any material and safe handling practices spelled out in material safety data sheets required of all manufacturers by OSHA. The second step, or steps, involves the commitment of the individual worker to follow correct handling procedures. A checklist of good health practices would include helping keep the plant clean, reporting defective ventilation systems so that they can be repaired, wearing a respirator, handling clothes worn during dust exposures in a risk-free manner. In particular, not cleaning clothes with compressed air, using dust collectors and equipment required to reduce dust, actively participating in all education and training programs offered, participating in medical surveillance programs for early detection of any changes in pulmonary function, and understanding all hazard communication materials provided by your employer. An additional health practice that can't be minimized is not smoking. Dr. Korn comments on this.
I'd like to address smoking in general. We're really talking about potential lung disease, a chronic potential lung disease called silicosis. The lung doesn't know what we as individuals put at its entry being the mouth and the nose. We can put anything there we want, and the lung has to answer for it. We're discussing a work environment where a potentially injurious substance is generated through the process of manufacturing, and we're minimizing the amount that will be taken into the lung. Smoking is a voluntary act that exposes the lung to absolutely humongous quantities of all types of agents, narcotic agents, asphyxiant agents, irritant agents, carcinogenic agents, and it has always been an incredible mystery to me how certain individuals can get upset with relatively minor risk to the lung and do this while smoking a cigarette, because the risk we're talking about is very great. Smoking is just an unacceptable risk.
In closing, the key is cooperation between the company and those employees who may be required to work with materials containing crystalline silica, making sure of the proper use of equipment, medical programs, training, and good health practices. Teamwork can result in safe handling of crystalline silica and good, sound health protection.